So good evening. I'm trying to share my screen. So good evening, welcome back to the genealogy season of the Core Enaction series. This is our first session, and I would like to briefly introduce this session through a recap of the genealogical path we accomplished so far. A genealogical path that in the introductive session, we propose to think as a participative exploration by the participants, the organizers, and the keynote speakers of the origins of the enactive approaches elaborated by Francisco Varela. The idea is that of exploring together the problem spaces, the ways of the emergence, the ways of the elaboration of this approach in order to prepare to foster its future development. And using Francisco Varela's word, we propose to think this participative exploration as an exercise of creative foresight. These were the words that Francisco Varela used to describe genealogical inquiries into the origins of scientific ideas and scientific approach. So what we propose is an exercise of creative foresight applied to the research path towards the enactive approach, an attempt of reconstructing the research path that led to the emergence of the enactive approach, and paths that we interpreted as the evolution of the research tradition to which Francisco Varela felt and he belonged to. This research tradition is the research tradition that Warren McCulloch in the era of cybernetics founded as the tradition of experimental epistemology, and he founded it in particular through his work with Walter Pitts, in terms of a research tradition dedicated to readdress the classical questions of philosophy of knowledge, in epistemology in this sense, through answers elaborated in terms of plausible biological mechanisms, in McCulloch's view, neurophysiological mechanism. And this by studying the mechanism underlying cognitive processes while they are in function, which from the point of view of Warren McCulloch meant not through the classical analytical method of science, but through the new synthetic method that cybernetic was developing in the first years of the emergence of the movement of cybernetics. A method that is oriented to understanding the complexity of cognitive and more in general biological mechanisms, not by taking them apart as required by the classical analytical method of science, but through recreating this mechanism through the construction of artificial models of them or through theoretical synthetic constructions. So during the introductive session, we explored the production of McCulloch and in particular with regard to his collaboration with Pitts. And we saw how a central idea emerging from a synthetic modeling of the cognitive mind was the idea that the cognitive mind is not a substance, but is a process, a dynamic and collective entity that is distributed in the activity of a network, which is emergent from the activity of a network or immanent in the activity of a network. This is the term they used, referring to the network of neurons that is constituting our brain. We also saw during the introductive session that the production of McCulloch and Pitts strongly influenced both the classical paradigm of the cognitive science, the computationalist paradigm, but also the embodied paradigm, in particular forms of radical embodiment. And this second branch of the influence that they exercised on the evolution of the cognitive science is given by the production of researchers who explicitly developed the tradition of experimental epistemology. And among these researchers, we find also Francisco Varela. And that's why we think we found in this branch of the development of the work by McCulloch and Pitts our genealogy of the enactive approach, the genealogy of the enactive approach, which we are exploring. In the introductive session, we accomplished 4 steps into the evolution of this tradition by considering the foundation of experimental epistemology by McCulloch through his work with Walter Pitts, then the further development offered to this tradition by the work of Heinz von Förster in the context of the development of second-order cybernetics within the lab he founded at the Illinois University Biological Computer Lab, then the further developments offered to this tradition by Umberto Maturana and Francisco Varela in the context of the elaboration of autopoiesis, and then the developments offered to this by Francisco Varela in his research path independent from Maturana, leading him to propose a theory of autonomous system in principles of biological autonomy, and then on this basis of elaborating the enactive approach. Always during the introductive session, we saw some key aspects of the evolution of this tradition, considering that the researcher developing explicitly this tradition described cognitive system in terms of biological networks. And on this basis, they characterize cognitive systems as autonomous systems, that is, systems that are relatively independent from their environment, where this relative independence from their environment is typically described within this tradition, this research tradition, through 2 theoretical terms: self-organization, which was used by Heinz von Förster and also by Varela in his independent research path, but also the term autopoiesis. And we will explore deeply these terms during our lectures, the following lectures. Also, another key aspect of the evolution of this tradition is the development of the idea that the mind is a distributed process, an idea that through the development of this tradition undergo a transformation leading from the thesis by McCulloch, according to which the mind as a distributed process is confined in the head, we can find it in the head, to the thesis explicit in Francisco Varela's work, according to which the mind is not in the head, but is in the whole biosphere, and maybe in the whole ecology, the interconnection of all autonomous systems. In the second session, we had a wonderful lecture by Professor Bruno Clark, exploring some segments of the evolution of the tradition of experimental epistemology. He focused mainly on the segment of this tradition leading from the foundation of experimental epistemology by McCulloch and through his work with Pitts to the second order cybernetics as it was elaborated by Heinz von Förster. And then he's also focused on the influence of Heinz von Förster on Francisco Varela's work, both in the context of the development of autopoiesis and in the context of his research path independent from Maturana. And today, in our first session, we will go on focusing on segments of this of the evolution of the tradition of experimental epistemology through a beautiful lecture by Juan Carlos Letelier, a lecture which will focus on the influence of the work of Heinz von Förster, both on autopoiesis and on Francisco Varela's independent research path. And without further ado, I will introduce then Juan Carlos Letelier, who is professor at the University of Chile in Santiago, and who was trained by Umberto Maturana and Francisco Varela in the field of neuroscience and theoretical biology. And these are the main fields of his research, fields in which he develops his main research interest, which is how we can use notions that are developed in neuroscience, in theoretical biology, and more in general in science to better understand our mind and our society. So thank you very much, Juan Carlos, to be with us. The lecture by Juan Carlos is dedicated to the origin of a very important notion that was developed along this path, that is the notion of structural coupling. So I leave the stage to you, Juan Carlos. Many thanks for being with us.
Perfect. Perfect. Bueno, thank you very much for the introduction. And now I will proceed. And, I need to apologize a little. My English is not the best. Then you will need to prepare your nervous system to work a little overdrive, yeah? Because then let me share with you my talk, if I can find it. Yeah. Then are you seeing the talk? Yeah, perfect. Then today we're going to see the origin of and the development of the idea of structural coupling. And first, this idea has a very humane origin and is the fundamental friendship between Umberto Maturana and Hein von Foester. And for you, if you don't know, Hein von Foester, excuse me, I'm going to put in a full. Hein von Foester was a physicist, an Austrian physicist, that during the Second World War worked in Austria developing radar circuits for using vacuum tubes. And very early on, in 1946, he arrives to the US, and he was protected by Warren McCulloch. And Warren McCulloch put him in charge of editing the transactions of the very, very famous Macy's conference that were a series of conferences, the most important from them from 1945 to 1954. And the topics of this conference were very, very important to us. By example, the relation of cybernetics at the micro level to biochemical and cellular processes. This was the topic of 1952, or studies on the activity of the brain in 53. These are topics very relevant to this course. And Hein von Foester had the job of editing the transactions in order to polish his English. And he was very good at that. And the next step, he got a professorship in the University of Illinois studying vacuum tubes, because at that time transistors were thought to be very secondary devices, But in 1957, something very important happened. The Soviets sent the Sputnik to orbit, and this was a big, big, big geopolitical surprise for the US. But they said, what are we going to do now? And then in 1958, the US went into what I will call a creation frenzy in order to close the technological gap with the USSR. And in one lapse of 1 year, they created many, many things. They created NASA for the space exploration, DARPA, the Department for Very Strange and Advanced Projects. They created something called the New Education Act that was essentially a way to encourage US citizens to study science and language, because under this new educational act, they will not pay college. It was paid by the state. And the fourth step is they created the laboratory of the future called the Biological Computer Laboratory, BCL, that this was a lab created mostly by the Navy and DARPA to create intelligent computers, because people realized very early on that programming computer was a very difficult task. And then they wanted computers that will auto-program themselves. And they put as a director, they asked Warren McCulloch who will be the director, and Warren McCulloch said, I have a man, this is called Hein von Foester, and Hein von Foester became the only director of BCL, and he's a central actor in what is going to follow. Yeah. But at the same moment, I need to tell you some history about Maturana. At the same period of time, Maturana was born in Chile in 1928. And by 1940, he was diagnosed with tuberculosis. And well, at that time, he was one of the first recipients of the wonderful drugs called antibiotics. And he saved himself from tuberculosis, but in 1948, he was in real trouble with tuberculosis. In 1950, he entered the School of Medicine at the University of Chile, but very early on, he discovered that he didn't want to be a doctor. And in 1954, he convinced everyone that he wanted to go to England and to study zoology and anatomy with the great zoologist J.Z. Young, who was a really distinguished biologist. And Maturana then went with a small fellowship from Rockefeller Foundation, went to study with him at London. But the British system, here you have the British system, didn't allow Maturana to do a PhD in Britain because he was not from a recognized university. The University of Chile was not a recognized center of high knowledge, and it was not in the British tradition. Then they didn't recognize anything that he couldn't do a PhD in England. But Young called his friends in Harvard and got Maturana accepted in Harvard, and Maturana did his PhD in Harvard on the myelinization of the optic nerve of the salamander. And when he ended his PhD, he crossed the river in Boston and went to work with this wonderful character, Jerome Ledwin, who had a lab studying visual perception. And with Ledwin, they did a fundamental work called What the Eye of the Frog Tells the Brain of the Frog. And this is a classical work in sensory neurophysiology. And in 1960, at the end of 1960, Maturana, fulfilling his promise to the University of Chile, he returned to Chile in order to get a professorship at the School of Medicine, even though he was invited to stay at MIT as a professor, but he said, no, I have this commitment and I want to respect it, and then he returned to Chile. And this famous paper, is What the Frogs of the Eye Tells the Frog's Brain, was done by Ledwin, Maturana, McCullough, and Pitt. And it's not the moment to discuss it, but it was a fundamental idea in sensory physiology that has to do something with the topic of today, because vision, according to the paper, is not, the neurobiology of vision is not an algorithm to decode information, but vision, in order to be properly understood, need to take into account the ecological world where the organism developed. Then it's not this embodied algorithm, it's algorithm that needs to take into account the ecology and the world of the organism or the organism under study. And bueno, in 58, Heinfeld Fester created, with funds from the US government, created BCL, and in 1960, he did like the debutante. I don't know if you have the word in English. The debutante ball of the laboratory in the University of Illinois, where he invited everyone who was someone in the world of self-organization. And this was, in some sense, the first conference on artificial life and self-organization. And it's called the BCL Conference on Self-Organization in 1960. And in this conference, you can see this collection of very interesting people. Of course, here you have Heinfeld Fester. There you have Warren McCullough. Here you have also a central character, Stanford Beer, who will be fundamental in the development of this story. Also, you have people like, like here you have von Hayek, the economist from the University of Chicago, who always thought that the economy was a self-organizing entity. Around here you have von Bertalanffy, and here in the first line you have all the big British cyberneticians. You have Sperry, in some place here you have Rosenblatt. Really, this photo is a really important photography to have. Then, excuse me, I'm having problems with my mouse. Yeah, then to know something very important happened next, Maturana and Varela, Maturana and von Foester met in Europe in '62, and they became instant friends. And von Foester then visited Chile for 5 to 5 months at the beginning of '65. And at that time, they stay, von Foester stayed in the house of Maturana in Santiago. And I'm sure that they must have discussed a lot of cybernetics, because this was the real topic of the lab of BCL. And von Foester begins then to help the lab of Maturana, who didn't have a lot of money. And they decided also that Maturana will go to stay one sabbatical year at BCL. Nobody knew when. But then this happened in 1968, 69. Francisco Varela at that time, in 1965, he was just a freshman, a very young university student who entered the newly created Facultad de Ciencias, where I'm teaching now at the Universidad de Chile. And also he managed to go immediately to Harvard, even without finishing his undergraduate degree. He got a fellowship to do the PhD at Harvard. And Varela went to Harvard then in September '67 in order to do a PhD that he will do it in very fast. He will be finished by October 1970. And then there at Harvard, Varela wrote a lot of letters to go to BCL, and then he visited, in fact, Varela visited BCL even before Maturana. As a young student in January '68, he went to BCL to give some talks about excitation and inhibition in the nervous system of frogs. And there also a very special friendship happened between him and von Foester. At the same time, you need to know that Maturana was in Chile doing his theory of color vision. But he wrote a long project, it's a long paper called A Relativistic Theory on Color Vision, where for the first time he put forward this theory that the nervous system doesn't detect a reality, but the reality is defined by a correlation of internal states. For Maturana, this was also always a very important paper. And then he spent essentially 1 year between September '68 and September '69 at BCL, where he wrote the fundamental book of the topic, that is the BCL technical report number 9, where in that technical report of BCL, that is the most important document produced by BCL, he claims that the brain is not a computer, it's not a Turing machine that analyzes reality, and that the brain is an action perception machine. I don't know how to, the brain is in a continuous stream of action perception, and that the objects appear as a side effect of the loop, as a side effects of the loop of the action perception machine, you have the creation of objects as regularities in the sensory motor coordination. And all kinds of objects, the teapot or the Schrödinger equation that I am putting there. And this is the idea that is written in BCL report number 9. This is, from my viewpoint, the people interested in this topic, you should really read this document. Excuse me. Then now Francisco Varela. Now I'm going to focus in the next period in the life of Francisco Varela. Francisco Varela was born in '46 and died in 2001. And there you see in a diagram with flag where he spent his life, and then he went in Chile, then from '67 to '70 in the US, then he returned to Chile during the government of Allende, and then at the end of '73, he, as many other people, had to escape Chile, and he went to study, to work in the United States. Then he returned to Chile from '80 to '84, And then from 84 to 2001, he stayed in Germany and France. And then he wrote a collections of very important books. Then in 1973, he wrote with Maturana, this is the fundamental book with the idea of autopoiesis. That the fundamental idea was already present in BCL in report number 9, and you know that the fundamental properties of autopoietic system is the closure, that is a circular organization where they self-fabricate essentially all the network, and the other aspect is that they produce their own enclosure, they are self-encapsulated. And also they discussed, they didn't prove that this was the most important consequence of the most important property. They put it like an axiom. They said a living system is an autopoietic system. Yeah. And this little red book explores the consequence of autopoiesis. You know, it's not a proof of autopoiesis, but it's an exploration of the consequence of taking this viewpoint to interpret biology. And the consequence is autonomy, the autopoietic systems are autonomous devices, and they have a particular way of creating cognition. This is crucial aspect, is the creation of cognition. Cognition as a biological fact. And they had a lot of social fun because they did a small computer program in a very, at the time was a very advanced computer, was an IBM 360, and there you have the simulation called the Protobio. I'm not going to go through this simulation, but in some sense they were the precursor of all the simulation of living systems using computers. And this is also a big step. It was, for current standard, of course, it's a very, very modest simulation, but it was a conceptually very important step. This was done in 1975. And it was done in 1973 in reality, and the paper was published in 75. Yeah. Later in the United States, because of the influence of Hein von Foester, who introduced Varela to the ideas of Spencer Brown and the indicational calculus, then Varela wrote the book Principles of Biological Autonomy, which is essentially attempt to use the indicational calculus of Spencer Brown to explore the idea of self-reference. Myself, I love mathematics. I discussed this topic many times with Varela, and I will say that this is an intriguing but difficult idea. It's a very complex approximation. It's impossible to put, until today, perhaps someone will do it, yeah? But it has been impossible to put ideas of metabolism inside the framework of indicational calculus. The lack of the dimension of time is only one problem, and it's not a fundamental problem, yeah? But it's a problem. And unfortunately, Varela wanted to build the theory of biological autonomy with indicational calculus, and I will say that he couldn't at the end. Yeah? And the proof is that after 1980, he didn't return to this very interesting topic. Huh? Then in the year 1980 is very important because the book called Autopoiesis and Cognition is printed in English, and Autopoiesis and Cognition is the translation into English and the presentation back-to-back of the two foundational documents. One is the BCL report number 9 of 69, and the other is the book, the Serie Macchina in Servio, is the book of autopoiesis. Then this book is the really fundamental book if you want to get into that, introduced to the theory. It's not easy reading because it has no equations, no diagrams, zero, they expect very, very motivated readers. Yeah, it's a very complex book, but it's a jewel. Yeah, and the introduction to the book was written by a great British cybernetician, Stafford Beer. And you can see that since 1980, systematically, the importance, the impact of the notions of biology of cognition, enaction, structural coupling, and autopoiesis is growing year by year. And today, if you do any Google search, you're going to find 1 million or 500,000 documents. Myself, I think that we're living inside an autopoietic wave. Yeah? And the proof that you have books that are called the autopoiesis of architecture, that initially you see how it's possible, but if you read, you find that the fundamental aspect that this type of text try to rescue is the idea of self-reference. And with the idea of self-reference, this very, very famous architect, Patrick Shoemaker, very, very famous architect in Europe, wants to build the theory of architecture based on the notion of self-reference and autonomy. It's quite surprising. And also you have people like Nicholas Luhmann that they say, no, it's not only architecture, but legal systems and societies as a whole are self-referenced entities and autonomous because of the idea of self-reference. Here I have some. And there we have, and in 1980, and I need to really thank Francisco Varela, because in 1980, Francisco Varela decided to return to Chile in the very, very difficult conditions. The University of Chile did suffer a lot during the dictatorship. Chile in 1980 was not a teacup, was a very difficult society. And he decided to return. And I'm always very grateful to him because I was an undergraduate student and he helped me a lot in getting the formation and defining who I am. And he stayed in Chile for 4 years until in 1984, he decided that it was impossible to do science in Chile. And then he went to France, to Germany. But in Chile, in that period between 1980 and 1984, with Humberto Maturana, they wrote this book, El Árbol del Conocimiento, The Tree of Knowledge. That is a book for the grand public to explain the ideas to the wider society, because really the book Autopoiesis and Cognition is not for the wider society. Yeah? Then they wrote this book, El Árbol del Conocimiento, who has been translated to 17 languages. And this is hard to believe, and this book was the result of a class, of a course, a seminar, a 1-year seminar that Maturana and Varela did every Wednesday. They went to the Ministry of Planification in Chile to an audience full of generals and right-wing people, including the daughter of Augusto Pinochet, and they talked to them essentially the same topics that we are touching in this class. It's amazing. They talk about the autopoietic system, the creation of reality, and you will not believe that Varela always said to me that some generals were really positive about everything. So, yeah. Then this is story. This book is essentially then the recopilation of the text of this class. Then also at the same time, something very important for the continuation and for the next phase of the life of Varela was he discovered Fourier analysis and the use of Fourier analysis to study brain activity. And he did this in Chile in '84, essentially because of his interactions with a great mathematician and collaborator called Jorge Soto Andrade. And this is also important because he became Varela in 1983. By 1983, he was quite astute in Fourier analysis as applied to biology. And he was going to be instrumental in a small little revolution that is going to happen in neuroscience a little later. Yeah, and this small little revolution is the theory of neural synchronization. Varela, at that time, had the intuition that the nervous system was like a family of uncoupled oscillators, and that during they were totally uncoupled, but suddenly in some moments, in every moment, in every second you had special periods where these oscillators will synchronize for a while, and then desynchronize again, then synchronize for a while, desynchronize again, synchronize for a while, and that the most relevant aspect was to study how this population of oscillators will transit from the non-synchronized to the synchronized state. Yeah, and this is called the theory of neural synchronization. That was going to be very important a little later. Then Varela, in 1984, went to Germany to work with Wolf Singer, who was the director of the Max Planck Institute. And there they work in ideas of neural synchronization and neural populations that will transit from one organized to disorganized state. He did a paper, in fact, a paper that was very difficult to publish. It was really difficult to publish, even with the name of Wolf Singer as an author, that by the time was very, very famous, because the ideas were totally orthogonal to the mainstream at that time. And but then Varela, in some sense, introduced Singer to this idea of neural synchronization, and Singer later will become like the bishop of the theory of neural synchronization, and he will produce also a little tsunami that will invade neuroscience, looking for synchronization and decided synchronization. I'm going to tell you that this little tsunami extinguished itself. By now, we think that neural synchronization is not as a fundamental phenomenon as Singer and Varela thought back then. Yeah? But from then on, from 1985 on until his death in 2001, Varela was very much involved in understanding neural synchronization and understanding embodied cognition. Yeah? And then he produced in Europe one very, very important book called The Embodied Mind at the beginnings of the 90s. And here I want to show that this idea that you can have a biological viewpoint about cognition is not an idea totally new. The first person, perhaps the first person who had this idea was Kant, but the first person who really wrote it down in a biological fashion was Jacob von Wexkull at the beginnings of the 1920s with the concept of Umwelt. Yeah. And in the 60s, US psychologist Gibson also had the ideas of affordances. And Maturana and Varela gave to this very phenomenon, this viewpoint of ecological cognition, or the fact that to know is to act, the different names, Varela called this enaction, and Umberto Maturana called this structural coupling. But both of them devoted quite a large amount of their time to clarify that concept. And here I am going to clarify the concept for you in my manner. This is how I view the phenomenon today, and this is an important cartoon. Yeah. Then, and I will show this cartoon many times in this talk. Initially at T0, at T0 here, you have that the autopoietic system, here you have the autopoietic system, is in some type of interaction with the medium. But if the interaction is recurrent, you have a lot of them, and recursive, suddenly the living system changes, and here you see the changes, with a congruent change in the environment, in the medium. And after a while, the living system has changed quite a while, and the medium has changed quite a while too, in a congruent manner. Then in some sense, the living system has learned how to create this object. Yeah. Then this is the idea of, this is the idea of structural coupling. And I think that I can produce a slightly better diagram. excuse me, wait a second. Then this is a fundamental idea that is not clear yet. Then that the objects are created by the interaction of living systems with the medium. This is, I prefer, now I do I have a better depiction of the same idea. Yeah. A better depiction of structural coupling. And here you have, you have at left, you have the organism who is in an undefined relation with the medium. But the organism is always in this action perception loop. And because it's always in this action perception loop, little by little, this undefined relation with the medium gets more and more defined. And at the end, you have a perfectly complementary relation between the medium and the organism that, from the viewpoint of the observer, gives the idea that the organism has pre-adapted to a has adapted to an existing object, and it's not at all the phenomenon that happened, because the real phenomenon is that the living system has created, to the mechanisms of structural coupling, has created a relation that is an object that, as an observer, we can denote it as an object, but really is an object not for the observer, but is an object for the living system creating this relation. Then this idea is not totally clear. It requires a lot of work. And here I have done myself a little cartoon with like the contribution of Maturana and Varela in these two crucial topics, that is autopoiesis and the biology of knowledge. And how, you have the first idea is the idea of Maturana of, I will call the loop, the perception action loop. This is the idea that you can find in BCL number 9. The second idea is the idea of autofabrication or autopoiesis with Varela. And the third idea is the idea of structural coupling that Varela and Maturana gave a slightly different version of the origin and the significance. And here I think that I am giving you a summary through this cartoon. It's a summary of the mechanism of object creations by self-reference living systems. But also it's important to understand that a living system doesn't act in the void. Then a living system, it's inside the living system, you have a mechanism that links perception to action. Then every living system must have, this is very important, that it's not in elementary theory, but every living system must have a sensorium, a sensory lamina, and how do we call an effectorium, a lamina of producing actions. Because a living system is an autopoietic system acting in the world in the envelope of a structural coupling or an action. This is very important, that the living system is an action machine. This is why biology of knowledge says that to know is to act. And here I don't want to go, this is impossible to go today, but what we are doing now in Santiago is that we understand that the mechanism that links, this mechanism that links perception to action, you can put this mechanism in the context of a Bayesian inference and of plasticity of a Bayesian inference method, mechanism. And then we think that living systems in this sense are intrinsic probabilistic devices. randomness is intrinsic to the action of a living system. It's not the randomness because you toss a coin that you don't know enough details about the coin. No, we think now that living systems are intrinsically random devices, exactly like electrons in an atom. This is what we are discussing nowadays in the lab, and we have been trying to publish some papers with no one else but Jorge Soto Andrade, who was very important. And also, I want to rescue in this talk someone who is a lone wolf and is a very important person because he was revolutionary, but he was totally unknown. He's called Robert Rosen. He was I will call a lone wolf of theoretical biology. His first paper is in 1958, 10 years before BCL report number 9. Is a very, very difficult, it's very, very, very difficult to understand all the texts of Rosen, but he was the first one to claim that the important portion of living system was their capability of self-fabrication. This is an idea of Rosen, and I know because I was there, because I know that I discovered in Chile the papers of Rosen in 1982, and I showed them to Varela, and we couldn't make any sense. I know that Varela and Maturana, they didn't know the existence of Rosen, and the texts of Rosen were so obscure that even though Varela and I had a very good mathematical education, we couldn't understand them. Yeah? And then because when he developed his theory of closure using a very complex branch of mathematics called the theory of category. But here I want to rescue first a book that you need to read, the people interested in this topic, you need to read Life Itself, the book that summarized the work of Rosen. And in the last talk, the presenter introduced like this analogy, of between indicational calculus here at the right. Here is indicational calculus, and here you have the ideas of autopoiesis. But amazingly enough, if you read Rosen, you can find something better, something that we call with Jorge Soto Andrade an Oroboric equation, that we claim that the mathematical object that will describe metabolism is something called F, that has the amazing property that F is at the same time a function, a variable, and a result. It's a very complex object, and this is very similar to that, by the way, if you think a little. And in fact, we have been discussing how we can make a link using this analogy between the indicational calculus of Spencer Brown and the ideas that we are developing here based on the ideas of Rosen. Also, I want to close this talk with some wonderful, crazy event that happened in the history of Chile during the government of Allende, and it's called the Cinco Project. And the Cinco Project is a wonderful, crazy idea. And the idea was that the Chilean government decided that they will cybernetize, I don't know how you say it in English, or they will put cybernetics in the Chilean economy, and the Chilean economy will be the first scientific economy of the world, and a computer will manage the Chilean economy. And this was called the Cinco Project, and the Chilean government hired no one else but Stafford Beer, who was a very famous business consultant in England, to create the Cinco Project. And Stafford Beer came to Chile, really, he bought a house. He really came with the idea of making this work. And the idea was that every Chilean company will have a teletype. This is before the internet. We'll have a teletype. We'll have a teletype with a network of teletypes. and all the information will be received in this very fancy control room that looks like the Starship Enterprise of the 1960s, with these very fancy seats where every fancy seat has these displays and computers, and you have displays to have the state of Chilean economy. And here, these 5 or 6 geniuses, by looking at the data and other things, they will decide that, no, Chile needs to plant 1,000 more lettuce in the north and produce 200,000 more shoes in the south. And there we will have a very modern economy. And this was the Proyecto Cinco. And incredibly enough, Hein von Fester was a consultant also to the Project Cinco. And in order to create the manpower to run the Cinco project, in July 1973, the best course on cybernetics was held in Santiago and the teachers and the professors were von Fester, Varela, Maturana, Schoenberg, Lawrence. I don't remember the name of all. I have the text and I have the reports of the class, of the course, and the course was called The Cybernetics of Cognitive Processes. And this course was given only to the engineers of the Cinco project. Yeah, quite amazing. And because I am a fan of this topic, I have managed with my friend to produce a copy of one, and this is where we have now to produce a copy of one of the seats of the Cinco command chair. And this is a picture we took the last week, and I would like to have one of them in my lab now. And then this is the story of the Cinco project that, of course, with the coup d'etat against Allende, the military, they didn't want to have this thing under the watch, then it was totally closed and destroyed. Then that's it. This is my talk. Yeah. And I hope that I didn't bore you.
Not at all. Thank you so much, Juan Carlos. I think we are going to have many questions for the discussion period, some of which have already been posted in the chat. But what I'd like to propose to everyone is to take a break if you need it before we actually launch ourselves into the discussion. So we'll take 10 minutes, and it's 6:55 p.m. in Europe right now. So we'll come back at 7:05 p.m.
Perfect.
So 10-minute break. Thank you again so much. See you in a few minutes. Okay, welcome back. So we already have actually several questions, several substantive questions in the chat. And why don't we start with a couple of clarifying questions that Karen had towards the beginning. Karen, do you want to just bring them forward, the two questions that you had? The first of which was about the context of the meeting between Maturana and von Förster in 1962. I think you also had a question about one of the slides.
Should I ask it?
Go ahead. Yeah, please go ahead.
Hi, everyone. So the first thing I wanted to know was the context of the meeting in Europe in 1962 between Maturana and von Förster. And the second question, but I think I understand it, is that on that structural coupling slide, is medium equivalent to environment? Do I understand that correctly?
Yeah, I will answer. First, the meeting, in 1969, sorry, in 1959, excuse me, Maturana and Letelier published this very amazing paper about sensory visual perception. And Maturana became for like 5 years, a rock star in neuroscience, because it was really, the result of that experiments was contrary the grain to the theory of the time. And then he was invited to many conferences. And then he was invited to a conference in Leiden, Holland, to talk about visual perception. And in that conference, also was invited Genealogy von Förster, but Genealogy von Förster went as a participant, because at that time BCL was very much engaged in bionics. They have promised the US government that they will produce bionic devices that will be very intelligent. Then Genealogy von Förster was looking to the new principles in neuroscience. Then he attended many conferences in neuroscience. Then it is in this context that they met in 62, at the end of 62 in Holland. Now, in that really, let me put the slide. Do you see it by now? You see it? Yeah. Hello, do you see it?
Yep, we can see it just fine.
Then medium, I think we call this medium here because the structure, the environment, the environment of a living system is a medium that has already the word niche inside, where the organism has built his ecological niche. This is environment. Then, and the construction of the niche is essentially structural coupling. The object that I am depicting here can be called the ecological niche of the organism. Then we think that initially the medium is some disorganized randomness in some sense from the viewpoint of the organism. And through his living in this disorganized entity from his viewpoint, he creates the order that we call an ecological niche. And then the environment is the medium organized by the process of structural coupling. This will be my answer today.
Great, thank you. Why don't we move to Chris? I know you had a question earlier on. Do you want to maybe articulate that for us?
Chris, me?
Yes, Chris, you.
Yeah, sure. So, you were talking about neurosynchrony sort of falling out of, well, not out of favor, but that it wasn't as much of, it's not as important as they initially thought it might be in neuroscience. And it had me thinking of, and I don't know if you're familiar with the Mountains and Valleys paper for the binocular rivalry, which I thought was a sort of a seminal paper for neurophenomenology, and how effective it could be with this first person, third person, what do you call a mutual constraint process, right? And that demonstrated, at least as from an observational point, that neural synchrony was important to, as it relates to the evolution of the perceptual moment, right? To experience. And I was wondering, just a comment on where neural synchrony is at today, or why you made that statement.
Yeah, well, this is a very important question. 30 years ago, in the early 90s, Wolfsfinger thought that neural synchrony was the angular stone, the principal pillar for understanding brain physiology. And the problem is that the brain has not very pure oscillators. We have very complex oscillator where it's really difficult to define the idea of synchrony is difficult to define for the case of the brain. And to the point that one of the contributions of Varela, a very important paper of Varela, was a method paper of how to assess synchrony. And this is a paper relatively late in the history of 97, 99, it's a paper, how to assess synchrony was a problem, and it's still a problem today. Then all the movement of neural synchronization began to lose importance because when you really apply more and more heavy statistics, you find that the definition of synchrony is not a well-defined same definition. And that in different occasions, you find things that you think that they were synchronous with other parameters they are not. Then this is why little by little this wave is disappearing.
Thank you.
But fundamental, two important contributions.
Great, thank you. Murillo, I think you had a couple of questions that came out. If you're able to unmute yourself, do you want to?
Yeah, so the first one was also, well, it's what he just answered. But the second one was, you suggested, especially in your abstract, that the notion of structural coupling is similar or related to, or maybe even, well, related to the notion of affordance. So I'm wondering whether you can explain a bit more what you mean by that. How exactly are these two notions related? And the follow-up question is, if these two notions are as close as you seem to be suggesting, why is it so difficult for us to talk to people working in the ecological psychology field?
And first, unfortunately, my dear friend, to give a real answer to this thing, we will need another media, yeah? Because myself, I don't do classes, I do performances, you understand? And then I need to move in like in a theater, yeah, to explain this. But because the idea of affordance, as thought by Gibson, who was a very clever, you need to read that. The idea is that here, excuse me, I will try, yeah. Here I am an organism that I have a lot of behavior that has to do with my ecology, with my how I live my life. And then suddenly I'm beginning to have some type of behavior in this direction. And initially it's a very difficult behavior to execute with very few rewards. But as I am beginning to do it more and more, I am beginning like to open a hole in the wall, and I can exploit this movement more and more, and I discovered that it's more and more positive for me. And then of all the complexities that I was doing before, now in exploring this new direction, I open a new venue where I can produce behavior and exploit this behavior to my benefit. And the word affordance is the analogy that is my behavior is like water, that opens, like in a riverlet, opens a dry river, and I move in the landscape. Then you understand? Then initially I cannot explore the total depth of my perceptual domain, but little by little I can advance and explore more and more and develop more and more, and I have more space to occupy in the domain of behavior. Yeah. Then this idea, without any doubt, is very similar to the Umwelt, structural coupling, and enaction. All these four ideas, they should be considered together. And from my viewpoint, the description of Maturana and Varela, different descriptions, are the most elaborate because they contain more biology, more modern biology. Now, the question about how you cannot talk with your colleagues in the ecological department, I don't know. We can hire some psychiatrists. I don't know. You know, I can send some. You know, it's impossible. People, they believe in certain things and they will not believe in anything else. This is the real reality.
Great. And by the way, this can also be a discussion, so I just want to encourage people, if you have a response or a follow-up question, please feel free. It doesn't have to be a
and Murillo, at least Murillo, did they answer your question, more or less the first one? No,
not to my satisfaction, I would say. I still want to understand a bit more how the notion of affordance can be related to the notion of structural coupling.
But the basic idea of affordance is this one, you know, that the behavior, you know, that you have venues of behavior that were not exploited, and then suddenly there are more.
Well, one way in which Gibson defines it is as opportunities for action, right?
Opportunities to action.
And sometimes this is phrased in terms of there is some that affordances exist in the environment in relation to the possibilities of actions of the organisms that live there. So I can see that these are, but I struggle to make sense of these two.
No, but no, is exactly the definition of gives is a possibility to action, but that you, the organism, is also the cause of the possibility. You understand?
Yeah.
This is why you explore initially, and then you open a venue, and then you are going to exploit that venue.
Okay, thanks.
Sabrina, Chris, go ahead, please step in.
Yeah, my understanding of that, the relationship is like, you know, let's take a climbability, right? It's like a Gibsonian idea, right? That something is climbable, so climbability. Well, for people like us, when we learn that something is climbable, like stairs, or, you know, it's already relative to our physical makeup, right? So that it already exists as something outside of our physiology or our, you know, anatomy, that's already specified mutually between us and whatever is climbable, and that is climbability. That's how I understand that. Anyway.
Yeah, but this is why structural coupling and enactions are better, because you don't need the objects to be climbable at the first moment. You understand? You construct the object to be climbable. You understand? This is why I think that the formulation of biology of cognition is superior to affordances and to the Umwelt of the Umwelt.
Okay, shall we move on to Sabrina? If you're able to unmute yourself, why don't you ask your question that you had in the chat?
Hello, thanks for the talk. And I was wondering if you can explain me, because I'm totally new to all of this. And is autopoiesis equivalent to homeostasis?
No, there are no. Autopoiesis is first is a theory of self-fabrication. That the system that will have self-fabrication, homeostatic, is a very in this context very simple theory of invariance for one parameter. So I have this very complex system, and this variable needs to stay at this level. And we have invented a method called feedback to maintain this level, not this one or this one. Then homeostasis is the mechanism by which this parameter stay at this level and not at any other level. The theory of autopoiesis is totally different. The theory of autopoiesis said, I am interested in the network, and the organization of the network, yeah, is such that you have some invariant in the organization of the network as a network of processes. Then it's a more, it's a vastly more ambitious theory. We don't have the theory totally developed, but it's a theory not about a single parameter, but it's a theory about the organization of a network that produces itself. Then it's, and this is why we don't have a theory, we don't have a real developed mathematical theory of autopoiesis, but we have a really well-developed theory of homeostasis, that is the theory of mathematical control.
Okay, thank you. Thank you.
I think Juan Carlo, do you want to ask your question if you're able to unmute yourself?
Yes,
thank you. Can you hear me?
Yes.
Okay, well, I think, hello, Juan Carlos, thank you for the talk. I think that you already answered this question, most of all when Chris talked about that. But maybe if you could elaborate further in the role of the observer, because the first thing that comes into my mind when I saw the diagram, it's, you know, the methodology, like, you know, the neurophenomenology, or it's like the observer is part of the environment, and for that reason, it also take part of in the phenomenon of coupling.
Wow. But you have different observers, because when you have an observer that doesn't interact with the organism, this is simple to talk about this observer. The complexity is when you have, for humans, you have a human that is an autopoietic system with his complex rules of structural coupling, and you have another human like him, and they interact to each other. Each one is an observer of the other, and then they begin to interact. And there you have the problem of language. Then you need to have a theory of what is an observer is. And this was one of the main preoccupation of Maturana in around 1990. Then for this, it's an important topic of the theory. You need to understand what language is in this theory. And remember, at least in this theory, language is not a mechanism to transmit information, but it's a mechanism to coordinate behavior. This is a crucial aspect of everything. You know, language is a mechanism to coordinate behavior in a recursive manner. Yeah, and then because an observer with respect to a living system of the same category, you know, they interact linguistically. It's different to be an observer of my cat than to be an observer of you. You know, now in this phenomenon, in this single experiment that we're doing now, we are interacting as observer of each other, and we're manipulating our attentional states, and we are trying to create new objects through these interactions. You know, I think that half of you didn't know what was structural coupling, and my purpose as an observer of the situation is to create an object called structural coupling that everyone can apprehend. Yeah? And to understand this, we need the theory of language. This is another class, but excuse me, I have a very old computer and my video sometimes stops. It's not that I'm escaping. It's not that I am escaping to say,
You're back. We can see you just fine now. Maria, you had a follow-up question about, you wanted to know if there's any specific references on language from an active perspective. So I don't know if you wanted to follow up with that, Juan Carlos.
Yeah, so one problem that I have, and maybe others will feel similarly to me. So I was trained in biology and then experimental psychology, but very much from the more dominant cognitivist perspective, and I'm trying to make this shift as best as I can. But even before going to the university, the way that we talk about our minds and our cognition is very much influenced by the computational metaphor, very much influenced by information processing. So if we want to start from a different perspective, which is what we're trying to do here, I think that there is an effort that we need to put in rethinking and redefining a lot of things. So if we start from the idea of structural coupling, we then need to rethink, what does that imply? How should we then think about things like attention, perception, action, remembering, planning, imagining, and so on. And I have not yet found, and I haven't looked enough, but so that's why I'm asking, I have not yet found resources that I can use to go through these processes in a more systematic way. So I wonder if this is already out there and I just haven't seen it, or if this is not yet out there. So how should we be thinking about attention, perception, action, remembering, planning, and so on? I know that there are different things around it, but how would you suggest that we go about doing it?
Oh, excellent. Well, first, you need a Russian linguistic has advanced a lot, and it's called Alexander Kravchenko, something. I will send, Alexander Kravchenko, you should read him. He's very perceptive, and he has developed some of these ideas in the domain of language. When you see the action, perception, unfortunately, modern neuroscience is still committed to exploit perfectly the metaphor of the computer, even if it's not true. But it's little by little losing weight. Then the answer is not easy, but you have now a new ideas in neuroscience, and look, the crucial aspect is the construction of objects through action. If we understand how we construct objects through action, we are one step ahead. And I offer to the organizing of this thing because I have developed an exercise where we can build an object here with Zoom. This is amazing. This has never been done in the galaxy before. It cannot be done here today. I don't need anything, but the only thing is that I have a class in 30 minutes. We can create an object, and we can discuss how we the rules of this object creation. You will be surprised.
Now you're teasing us. You have to deliver your promise.
I can talk with the bosses. I offer a special, perhaps.
We will organize that. We will organize.
Organize. I will create an object in front of you. Not only am I going to create an object, but I will create a sport in front of you. You will be amazed. Because the fact is that we define ourselves in action. And then this is why the problem is that most of neuroscience, and I am a professional neuroscientist, has been devoted to sensorial neuroscience. for many decades, we thought that understanding the perception will be the key to understand the working of the nervous system. And this is why we invested a little mountain of money to crack the secret of the visual system of monkeys and cats. And by the way, killing a little mountains of little kittens and little monkeys. Yeah. And but we didn't work to understand equally well the motor system. Then here we have a very big gap in our understanding of how the brain controls the motor system. If we diminish this gap, we will understand how action creates objects. And this is the crucial aspect to understand.
Any follow-up, Marito? No,
No.
Okay. Okay. We do have another question from Georgina. Her microphone's not working, so I can just read it out and then we can maybe bring this into the discussion space. She says, how can we define attention? How could we define attention? Is it possible to define it as an emergent process of a conscious agent?
It's a process. You don't need to be conscious to have attention. You can have attention. Pigeons have attention. Cats have attention. And I don't think that they are conscious in the same way that we are. Because the problem, I need a blackboard. We need to develop the theory of blackboard. And I don't. Look, what is attention? I will explain you. The attention is an emotions, they're related. In every single moment, now, in this moment, every one of you have thousands of neuronal processes going on in your mind. You can decide, should I stay listening to this guy? Should I go have a tea? Should I go to see the TV? Should I call my little cat to pet him? Should I call my wife? Etc., etc., etc. You have millions of actions. Should I study quantum mechanics? And you have a method that organizes of all this universe of actions. You have continuously, you have a subset of actions that are the real actions that you can perform now in the next 5 minutes. In these next 5 minutes, your actions are only a few of them. To continue here, to live because if you find that I am totally crazy, or to do a question. To ask a question. And then the process of selection of all the possible actions to define this small subset of actions that you're going to perform or not in the next 5 minutes, this is the role of emotions. And at the same time, you have a role in perception to define of the thousands of objects that can trigger your visual system. You only pay attention to a fraction of them. Yeah? Again, it's the problem of selecting from a big universe of possible objects, selecting the few ones that you are really putting attention. And this is a neurophysiological process that we understand how it's more or less now, how it's done. And for us, in this community, the trick is to understand how action is related to the problem of perception. Action and perception are related because the actions that I perform define my action, my attention in the next few seconds. Attention is not a disembodied entity, but it's a neurophysiological entity that has to do with the trajectory of actions that I have performed in the last 5 minutes. You understand that this is why action, the loop of action affect your perception because it affects your attention. This is my answer. They're all very difficult questions today.
We're diving deep today. This is the deep dive. Georgie, she can't unmute herself, but she said thank you so much. So I'm assuming that there wasn't any more follow-up to that. And we still have a few more minutes, so we can just leave the floor open for any follow-up questions or any thoughts on what's already been said. If you want to go deeper into one of the questions, feel free. We have about 15 minutes left.
No, then, if I think that this, action perception, the basic theory was born stating that the basic loop is this action perception. But neither action or perceptions are simple concepts. Perception is not a passive concept. I am not a passive container where I am, the universe fills me up with percepts. Here you have the cat, the wife, the political turmoil in Europe, the life and death of Boris Johnson, all of these are percepts. No, I am not a passive agent. Because I act on the world, the perceptions that I have, in some sense, are created by my particular pathway of actions that I am taking in every little second. Because if I turn, instead of seeing you in the Zoom screen, I see the mess of the books in my office. You understand? Then a simple action, by this very fact, the actions that I took, to change my chair, change my perception, change the angle where me as a living system, the angle of attack that I'm going to confront the universe, and then it changes the universe, the universe of percepts, and then to select which object is going to control my behavior next. This is the mechanism of attention in one side and the mechanism of action selection in the other side. And then I am always in this loop and I cannot be out of this loop. And this is the core of the theory. Then in some sense, look, something wonderful has just happened. I have a hidden synapse between my muscles and my photoreceptors, because I can affect the activity of my photoreceptors by the activity of my muscles. If I change, I am seeing something completely different. Then I am modulating the activity of my photoreceptors are modulated by the activity of my muscles. Then in some sense, I have a synapse because I affect the neural activity of the photoreceptors. I affect that activity by the activity of my muscles. Then I have a synapse. Essentially, here I have a neuron, and here I have a muscle that is like a neuron, and this muscle affects the activity of this neuron, and I have like a synapse that happens by my activity in the world, not by a molecule inside of neurotransmitter. And then this is the fundamental. This is a really important idea to have. Chris has a question.
On that same line of thought, how would you talk about, let's say, like the inner loop, as it were? Like if I am partaking in concept, I'm playing around with concept formation. Are we, as an action within our own heads thinking, right? We're playing with concepts. We're coming up with new concepts. How would you speak about that? It seems clearer when we're talking about, our actions in the world, going about selecting objects for perception that are meaningful to us. But when it comes to, concept formation, is this like a dance going, on between, premotor function and our memory? Or how would you think about that in sort of from an active view?
No, I will say that every object that you can describe, essentially, what is an object? What is a cat? A cat is the list of behaviors that I can have with respect to the cat. I can feed the cat, I can pet the cat, I can tell to my cat that she's the most beautiful cat in the neighborhood. For me, the cat is a collection of actions that I can take with respect to an object. And then every object is like that. Every object is a collection of actions that I can take with respect to that object. Then if you show me another object, what is an electron? I said, an electron is always a metaphor. Essentially, we live in a world of metaphor. I don't know if you have the verb metaphorizing. You understand? We create metaphors all the time because we use actions to produce objects. And these objects create more actions. Then you cannot escape that loop. And then we use metaphors to create new objects because we created new actions. You see? In the sense, what is a lion? You said, a lion is a cat, it's a bigger cat. You need to be aware of that. So he has a bad temper. Perfect. Then this is lion is a cat, bad temper. And then both of these labels, they point to specific behaviors that I can have with respect to that label. You understand? Then the idea of metaphors is fundamental.
Juan Carlos, I would like to ask a question also related to the Cinco project, and I think that emerges from all the questions we have. So if you're going to realize this shift, this reconceptualization from neuroscience, but also more thinking to our cognitive processes, basic concept of philosophy of mind, what can be the impact on our personal life, on our life as inhabitants of the planet with regard to the global ecology? What do you think are the impacts that these new ideas can bring if they would become, I don't say the mainstream, but at least a point of reference, a strong point of reference in our culture?
No, we have, look, myself, I respect nature, but ecology, and I need to be honest with you, and climate changes are not big in my level of preoccupations, because the world, you look at the world different from Rome than from Santiago. Our problems here are a little different. But if these ideas that we're exploring in these courses are true, we are going to create complete new way of thinking, because we're going to create new ways of new families, new lineages of objects that are not grounded in metaphors that now have tired themselves, como se cansaron, the metaphors that are already agotadas, metaphors that are at the end of the road, you understand? Metaphors that then, by example, the metaphor of the computer is at the end of the road for studying living systems. Then if we can understand the ideas that we're exploring in this seminar, we will be able to create new ways of thinking. Especially, this is, I will not, anticipation. Because the idea of structural coupling or enaction contains inside the idea of anticipation. Then, if we can develop this theory well enough, we will have a new way to describe the future. Because for us, the future is a complex function of the present. You understand? Do you see the equation, sir? The future is a complex function of the present. This is the fundamental equation that of the West. But perhaps it's not like that. Perhaps the future is a complex equation of our model of the future. Then the idea of structural coupling contains inside the idea of anticipation. Then if we can build around that, we will put a new way of thinking, a new one. And also because the coherence in a structural coupling is not the logical coherence, you understand? The important is not, we can accept in the logic of structural coupling of enaction that something is and is not at the same moment. For us, it's not, for us, in the normal Aristotelic logic, this is very difficult to accept as a normal viewpoint. But in this view of where it's based on the ecology, of in our life, perhaps we can accept that something is and it's not at the same moment. A concept that is central to the Aymara philosophy and is called Chixi. Then we will add a new, a new postulate to logic, if we were able to develop this theory. This will be my answer for you, Luisa Damone.
Thank you very much. I wanted also to ask if there are not other questions that are emerging from what Juan Carlos is saying. What do you think of the idea of a framework of complementarity on which Francisco Varela was working, in a sense that if you think our cognitive processes and our knowledge as a co-construction, so we have to have the maximum respect for others, for other constructions. And this should be applied also, he was saying, also to the computationalist view of cognitive processes. So we should be pluralist in this sense. What is your position with regard to this?
My position is that you should respect all actions of living systems, because they're more or less, we are equally, me, my cat, the bacteria, we are in this planet. We are the result of a very complex of structural coupling of a lineage that has changed the planet. And as an ethic, you need to respect the creation of the other, because if not, we are in the crisis that we are now. Yeah.
So this crisis is due to the fact that some ideas are destroying other ideas and dominating on other ideas instead of having a complementarity, a mutual constraint approach. Do you think we can go in this direction, think in this direction?
No, I will change completely your question, but I will rescue the central point. Look, today, my viewpoint is that the normal viewpoint that I was taught in the university almost 50 years ago is totally tired, is totally épuisé. And now what happened is that now I don't want to read any more scientific papers. If you read, if I open the Journal of Neuroscience, I think that all the science that we're producing has no imagination, doesn't open new worlds. It's the most boring science. Then I think that the metaphors that we have used for certain aspect of science, we have condemned ourselves to a tunnel. We have dig ourselves in a well because of that, and we are producing a science that is not interesting anymore. I wish now I cannot be. I would like to be a quantum, to do quantum computing, but I don't know. I need to invent myself. I need to born again. But in biology, neuroscience, the normal paradigms are boring. When you read a paper, they're totally boring. It's nothing new. I will present it in this way.
Thank you. I think there is Jose.
Jose, go ahead.
Yes, I completely agree with Juan Carlos that neuroscience has become very, very boring. But in order to make it more interesting, we should be able to convince as an activist of changing the views, right? And I think one way to do this is trying to clarify some concepts that are still very vague. So one of them is the concept of structural coupling. I think is very fuzzy, as opposed to, for example, the concept of affordances, which is very, it's very easy to relate to that concept. It's very clear. So maybe I will try again. I will try to reinstantiate the question by Murillo in the beginning. So how can we establish a relationship between the concept of structural coupling, which is very abstract, and the concept of affordances, for example? In order to make the concept of structural coupling more, like with the fingertips, like to develop a fingertip feeling, because it seems to me intuitively that this concept is somehow gives an account of the ontology of affordances, how they are created. Can you give us your view about this?
If you want answer, look, someone who has thought about this is a guy called Friston, yeah, with his free energy principle. Friston,
but that's even more difficult than
this is even more difficult. But then means that you have an opportunity. We need to think a little. Myself, at the rate that we can do it here, and not being a mathematician, I really think that to put structural coupling in the context of Bayesian inference is a fundamental aspect, and this is what we're doing now in the lab. Yeah. Then this is why, because we're intrinsically probabilistic machine that through our choices that are random, we create the objects that we find, the objects that populate our niche. And I think that we can do that some type of formal analysis in using Bayesian inference. Yeah. But some people like Friston, they claim that they have solved the problem, but I don't think that they have a real solution. But if people is interested in this group, you should go and read the paper of Friston, and you have some papers called, if you Google, if you Google autopoiesis Friston, you're going to see no one paper, like 3 or 4 very, very modern and very interesting papers. Difficult to understand like hell, but it could be very interesting.
Great.
Yeah, I think that.
Go ahead.
No, I think that we are done. No?
I saw just one hand. Chris, did you want to make one final comment, or are you good? Go
yeah,
ahead.
just quickly on what you were saying about the actions that we choose and the randomness. There's a set of whatever we have so many that we can choose from. Would you talk about just is there any teleology there? I mean, with respect to the system being at where it is based on its past, and then going forward, it must have a trajectory, right? So that that when we say we have possibilities for action, there has to be something moving forward from the past that's carrying us into those new choices, right? I mean, is that
no, I don't think that is teleology, because it seems that living systems is like we are these little machines. We have bacteria, I don't know where they arrived 4,000 million years ago, and these bacteria, everyone, they created a lineage, and now you have the same bacteria, or the descendants, but bacteria, and you have living systems, and we have populated the Earth, and in this population, you populate the planet, we have changed, we have created all the objects, including the oxygens, the plants, everything. Then living systems, they don't have to fulfill some major principle, because you have so many living systems, and each lineage explores his own version of structural coupling, and each version of the structural coupling can change the universe, that at the end doesn't matter.
So you don't see there being like something like an eminent purposiveness type of
because the purpose of me, the elephant, the whale, the bat, the lamprey, the spiders, everyone is acting like in parallel because of their autonomy. This is the miracle of autopoietic system. They have autonomy, and then in doing this autonomy, they transform the world where they live. And the transformation is quite pronounced.
The purpose is in the eye of the observer.
Exactly, the purpose is in the eye of the observer. The only thing that happens is that in every single second, the living system is an autonomous device that needs to act in the world that he has created, he has just created.
Oh, but aren't we creating it from the same stuff? Like, it's all the same. I know it's relative, but it's also you know, we find similar structures, you know, when we have analogous forms and, you know, throughout all of biology, right? So there's some sense in which that there's a shared sort of trajectory to all of, you know, all of living things. When, you know, when there has to be something that grounds us to enable us to communicate, or to, you know, to recognize in the behavior of similar systems, right? That there's something analogous there for us to grab onto, and it seems like if that's the case, then wouldn't there at least be even though it's not identical, it's not like isomorphic or something, but like that there's some sense of a shared trajectory, even if it's open, that there's at least, you know, something that bonds everything, right? I mean, structurally speaking.
See, but from the point of view of knowledge, of generation of cognition, my universe, my Umwelt, is totally different from the Umwelt of my cat. I think that we live in the same world, but we live in a totally different world. You know, my Umwelt is totally different from the Umwelt of the cat. And the beauty is that we can relate more or less, but who knows? You know, myself, I appreciate my cat very much. My cat discovered that I had lung cancer, and I survived because of that. Yeah. And in some strange way, my cat communicated this to me. I will tell you. Then I think that the Umwelt of everyone is totally different from the Umwelt of the other species. Yeah, my dear friends, myself, in 5 minutes, I have classes.
Yes, so
Thank you so much. Thank you so much, Juan Carlos, for this beautiful lecture, for involving, for this involving discussion, and thank you all for this intense participation to the discussion. This was really great. Before closing this session, then I would like to remind you of the next session next week, next Wednesday. We will have a lecture by Tom Zinke about autopoiesis and the origins of Enaction. So always at 6 o'clock CST.
Perfect.
Great, thank you. And we also have a talk tomorrow for those who are interested from one of our European Varela Award alumni, Michelle Carr. She'll be talking about her research tomorrow at 6 p.m. So we look forward to seeing you either tomorrow or next Wednesday or both. Thank you so much. And thank you again, Juan Carlos, for this absolutely fascinating lecture.
No, thank you for inviting me. And remember, I want another class to create an object.
Absolutely. This is
object creation. Yeah?
We will see you back here soon, very soon.
Very soon.
Perfect. Yeah?
Thank you so much. Bye. Have a nice class.
Bye.
Bye. Have a great evening, everyone.